Right then, graph transformations. The key thing to understand with graph transformations and a lot of what you do with functions is the idea of an input versus an output. If you approach any functions question or any graph transformation question with the mindset of, am I thinking about changing the input versus changing the output, you are going to be in a much stronger position to answer that question. So we are looking at input versus output. If you have a function, f of x, and you plot that function, that is your output. That is what you get out of it. The x is your input, okay? On a Cartesian axis, you have an x-axis and a y-axis, and say your function looks like this. You are plotting the line y is f of x. If you change your input, you are affecting the x direction, so horizontal. If you are changing the output, you are affecting the y direction, right? The vertical. So let's think of a standard transformation. So say you have a function, f of x, and you change that to f of x plus a, right? Let's take x squared as our function, and we were to change that to x squared plus 2. That is going to be a translation in the y direction through a vector 0, 2. All you are doing is shifting the graph up. If you were to change the input, so we now have f of x plus a, for example, so x squared could go to x plus 2 squared. That is now a translation in the x direction. Does it go right? Does it go left? With x, it does the opposite of what you might think. So plot positive 2, you might be thinking, right, that moves to the right. But it actually moves left by 2. And the reason is because you're affecting the input to get the same output. So say for x squared, you plug in 2, you get 4, right? For your new function, having been transformed, your new value of x, in order to give an output of 4, i.e. the same value, your x value has to be 2 less to give you that same output. So it goes left rather than right. So that's your translations, right? If you were to multiply, so say you had a function, and you were to multiply your function by some constant, for example, x squared goes to 2x squared, you are stretching it in the y direction. We are doing something to the function, the output value. So say I multiplied x squared by 2, that is in the y direction with a scale factor 2. Now moving to the x, if I multiply my input by a factor a, for example, x squared goes to 2x squared, we are now looking at changing the input, we are now looking at the x direction. So this is a stretch in the x direction. What is the scale factor? You might think positive 2, scale factor of 2, right? But remember, this is the x, you're changing the input. In order to get the same output, what do you have to do with the x? Well, x has been doubled, so we are going to have to half the value of x to get the same output. So this is a scale factor of a half. It gets squashed, okay? So those are your stretches. Now on to reflections. You might have covered reflections already, and you might be thinking, oh yeah, but what you're saying doesn't work, because if I change the x, i.e. the input, that's a reflection in the x-axis, right? And I'm about to prove that while that is true, there's another way of thinking about it. So take my function, f of x, and I apply minus sign, minus f of x. What am I changing? I'm changing the output. If I take x squared and I make it a minus x squared, what have I done? Well, this is a reflection, right? In what axis? Well, If I take my positive output values and I make them negative and I make my negative values positive, you can clearly see I'm moving in the y direction still. So that still works. It is in the reflection in the line y is 0, what we would call the x-axis. So although you might be thinking, well, I'm changing the output, but I'm now looking at the x direction, you aren't. You're looking at the x-axis, which is actually the y direction, the vertical direction. If I take the other function and I make it f of minus x, for example, x squared, which is minus x squared, which is actually just x squared, I'm taking my negative inputs, making them positive, and my positive inputs making them negative. What direction am I moving them in? The x direction. That is in the reflection in the line x is 0, or the y-axis. So for all three, your translations, your stretches, and your reflections, think to yourself, input versus output. Am I changing the input? If so, I'm looking at the x direction. I'm looking horizontally. If you are changing the output of the function, you're looking vertically in the y direction. Applying that to any graph transformation is going to be massively helpful. And I would argue that you should play around with some graphing calculators like Desmos and just see, if I make this negative, what happens. If I change the x value or the output, what happens, and just play around, and it will become clear that input x direction, output y direction. That's what you've got to think. I hope that helps. Let me know in the comments if you want me to do anything else, and I'll see you in the next one.